The concept for beta angle in projection of solids. So what is the concept here is if the angle of inclination to the HP and VP, say both the inclinations to the HP and VP, if it is there with the axis, then it is a beta angle problem. Okay, beta angle problem in projection of solids. So the same concept it is related to the prism and pyramid also. So you have to see that if the angle of inclination it is there with the axis for both HP and VP, then it will be an beta angle in the projection of solids. The same concepts hold good for prism, pyramid and cone. Welcome to Engineering Visualization channel. Problem number 8. A pentagonal prism 25 mm sides of base, 50 mm axis length rests on HP on one of its corners of the base, such that two base edges containing the corner on which it rests make equal inclinations with HP. Draw the projection of the prism when the axis of the prism is inclined to HP at 40 and VP at 30. So here first we have to construct a pentagon. In the first position we have to construct a pentagon, okay, of dimension 25 with respect to corner here. Given in the question, corner of the base, that means we have to corner on the right side. We know that in solids, right side is the reference for considering the base corner. Okay. Now here type of the problem. So which type we have to identify. Here the type of the problem here, the axis is given for the inclination to both HP and VP. So axis given means it is nothing but beta angle problem. Okay, beta angle problem, because axis is given for both HP and VP for the inclinations. Okay, now we are going to construct an XY line, okay, using the sketchbook sheets, okay, grid sheet, using grid sheet, because many of the students are using the grid sheet in VTU. So we will be considering the same thing here. First I will be drawing an XY line, horizontal line, exactly at the middle of the page. Okay, use the scale and draw a straight line. Okay, draw XY line and mention VPHP. Okay, because we are using first quadrant, so we have to mention this VP and HPs, remember it. And now we have to construct a pentagon. Okay, pentagon with respect to corner position, okay, which is of dimension 25. So using the scale, draw a line of length to 2.5 centimeter at 25 mm. Then use the protractor here, protractor for marking an angle of 72 degree. Outer angle we have to consider here, remember it, 72 degree exactly we have to mark. And now passing to that angle point from the reference end, we have to draw a line of length 25 mm, that is 2.5 centimeter from the scale we have to draw. Same way on this end also we have to mark an angle of 72 degree. Okay, and draw a line passing through that angle point, length of 25 mm, that is 2.5 centimeter. Draw a line. Okay, now using the compass, measure 25 mm from the compass and cut the arc. You measure any one of the length here, because all the lengths of 25 mm only. By keeping at that reference point, cut the first arc. Okay, and keeping at the second reference point, cut the first arc. Now you are getting a cut point, so join that arc cut point for this end point with the straight line using scale. Join it. Okay, you can give the naming for this. In prism we know it is having two face, top face and bottom face. A, B, C, D, E is the naming of top face. A1, B1, C1, D1 and E1 is the naming of the bottom face. Okay, which is not visible from the top view, that's why it is written within brackets. Okay, now show the dimension for one edge here. Here I'm showing for one edge as 25 mm. Mention 25 mm here. Now we have to draw a perpendicular bisector here. I'll be drawing two perpendicular. You know how to draw. So you need to draw a line exactly. First mark the midpoint of the edge and try to connect with the opposite corner using straight line. Okay, marking the midpoint and then try to connect with the opposite end. You will get the perpendicular bisector. Now we are getting the center, that is O1. Okay. Now draw the projection lines to construct the front view here. So here projection lines should be thin lines here. Make sure you should draw the thin lines. Okay. So in the problem given the axis height, in the problem given axis 50 mm it is. So here the front view of the prism, okay, front view of the prism, it is a rectangular face. So here first I will be constructing a axis for a dimension of 50 mm. Same way you can draw here vertical lines for a length of 50 mm. Draw the rectangular face here. Okay. So show the front view dimension. Here front view dimension it is 50 mm. Mark the dimension of 50. Okay. Now we can write the front view namings. So from the front view, B dash, C dash and D dash visible, A and the E dash not visible. So B dash visible here, C dash visible, D dash visible, E dash and A dash in bracket. In same way for the bottom face, B1 dash and A1 dash not visible, C1 dash visible, D1 dash visible and E1 dash not visible. In same way axis center O1 dash and O dash not visible. So now we have done with the first position. Now we have to construct the second position. For the second position they have given inclination to HP 40 degree with respect to axis. Okay, but we will be constructing using the base edge here. Okay, so base edge inclination is equal to, we know the formula, 90 degree minus angle of inclination to HP. It is given 40. So 90 minus 40 degree means it is 50 degree. First I will be marking a reference point, that is D1 dash on a XY line. Okay. Then place the protractor and mark for angle 50 degree here, because base edge angle is 50 here. Now draw a line passing through that point. Okay. Now using compass we have to cut the arc. So the reference point here it is D1 dash. We need to measure from D1 dash to B1 dash. That is our first arc we need to cut on the angle line. Okay, measure it like this and cut it. And this point is nothing but B1 dash and E1 dash. Okay, A1 dash. The second arc should be from D1 dash to O1 dash for the axis. Okay. This is your O1 dash. Now the third arc we need to cut from D1 dash to E1 dash, that is C1 dash you can say. So measure the arc length and cut it. Okay, now we can see for this base edge here, these vertical lines are exactly perpendicular. You can see this, all these four lines are exactly perpendicular to the base. So what we do, we are going to use the protractor and mark for angle 90 degree for all these reference points. Okay, place the protractor here, mark for angle 90 degree, fix up for the C1 dash here, mark again 90 degree, same way mark for O1 dash axis point, mark again 90 degree, then fix it for the last corner point. Again you mark for 90 degree. Okay, now using scale, so we should be drawing for that 90 degree a length of 50 mm, because it is the same length we should copy here. So draw a line of length 50 mm. Count it 1 2 3 4 5. So till there you have to join. Same way for the axis also. To that reference point we have to draw an axis. Now we can connect from C1 dash to, from there you draw one perpendicular line for a length of 50 mm, and again for the D1 dash also you draw one line which is of length 50 mm. You can now draw the top face by joining all this point. Okay. Okay, now join the top face, write the top face notations: B dash, A dash, O dash, C dash, and E dash, and D dash. Okay, now we have to extend this axis to show the angle, because angle of inclination to HP they have mentioned with respect to the axis. So we need to show the angle for the axis only here. Okay. You can cross check the angle using protractor. So it is exactly 40 degree. Okay, that's what the angle given in the question, 40 degree. Okay, now draw the projection lines downward to complete the second position top view. So draw the projection lines here vertically downward one by one from all these reference points. So draw straight lines. Okay, horizontally also we need to draw the projection lines. So use the scale properly and draw the horizontal lines. These lines need to be straight. Okay, so use the scale properly in order to draw the straight lines. Okay, now we can write down the namings for the second position top view. First I'll writing for the bottom face. That is, bottom face is A1, B1, C1, D1 and E1, and this is O1. Same way for the top face, A, B, C, D and E, and mention the O here. Now to construct this second position top view, we will be following 3 steps here. Okay, to construct you can say second position top view. So this concept will be holds good for all the prisms and pyramids. First step is writing the outer boundary line. So outer boundary line we have to draw, that is from A1 to B1, B1 to C1. We need to connect it using the scale here. So just draw the straight lines connecting it: A1 to B1, B1 to C1, then C1 to C, then C to D, then D to E, then E to E1, then E1 to A1. So this forms an outer boundary line. Okay, now the second step is writing the visible faces and the edges. So we have to write or construct the visible faces or the edges. Okay, that is our second step. So visible faces and edges we will be constructing using continuous line. You can see as we are looking this diagram from the top view, this position, okay. So as we look from the top view, so this face is visible, right? From the top view, this top face is visible. So which are the visible face? Here the top face is a pentagon. So we will be connecting all this with the continuous line here. Okay, you can subscribe to my channel and hit on the bell icon for the latest notifications and share it to maximum students so that they can be benefited. And this rectangular face also visible here, that is A to A1 and B to B1. So this also you connect it with a continuous line. Okay. Now the third step is writing the hidden faces. Okay. So constructing the hidden, or you can say invisible faces and edges by dashed lines here. So we need to use the dashed lines here. Okay. Say you can see here the bottom face of this pentagonal prism not visible, but already a part of the pentagon we have written with a continuous line. So here there is a concept called if there is a merging. Okay, if there is a merging of continuous line with the dashed line, we need to show only the continuous line here. Okay, if there is a merging of continuous line with the dashed line, we need to show only the continuous line here. We have to show the continuous line. That means we will be showing only a part of the pentagon with the dashed line here. You can say because already we have constructed a part of the pentagon with the continuous line. The remaining part, okay, the remaining part we will be constructing using the dashed line here. So try to join with the dashed line here. Okay. Now this head is also not visible from the top view, that is D dash and D1 dash. As we try to write in the top view, it will be from D1 to D. Okay, that will be the dashed line here. Okay. Now you can see here we need to write finally the axis here. Axis from O1 to O, but part of the axis I can show because there is already a dashed line there. Now the third position. Okay, now the type of the problem here, it is beta angle, because they have given axis of the prism is inclined to HP at 40 degree and to VP at 30 degree. So for that angle line we have to draw like this. From their reference point I will consider and draw an angle line for 30 degree. So inclination to VP they have given in the question, it is 30 degree. So you need to make sure the space which is to be constructed here, make sure that the second diagram when we try to copy, it should not merge with the XY line or it should not leave the page. Okay, like that you try to draw the angle line. You should be here careful. Okay, when you are drawing an angle line, I think I should take the angle line little lower so that the diagram can be copied easily. So now from their reference point you can mark an angle 30 degree. Okay, mark for angle 30 degree. So from that point I will be considering the angle line little lower. Okay, as I mentioned, you should not merge with the XY line or with the second diagram. Okay, draw an angle line for 30 degree. So this is having angle of 30 degree. Okay, now so we know that in the beta angle problem it is with respect to the axis we have to do. So there are two axes given, 50 mm front view, that is your first axis, and the second axis length is second position top view. So this is your second position. So we should be considering this length, okay, as your second length for cutting the arc and finding out the beta angle. This is your second length. Okay, so first axis length we have to use this one, that is 50 mm for cutting the arc. Okay, so this is your second length we should consider. Okay, second axis length. So first axis length given in the problem, it is 50. First you take a reference point. Okay, take a reference point, that is your O. Measure the length of 50 mm. Okay, from the compass and cut an arc. So here axis length is 50 mm. So measure using compass and cut the arc. And to avoid the confusion here, we will be giving this as O2. Okay. After cutting an arc, we should draw here locus line. Locus line we should draw here, where exactly it has cut it, right? So draw an locus line. We'll be mentioning this as locus line. Okay. Now the second arc we should cut, that is from O to O1. From the second position top view, from there to there, we should measure using compass and cut the arc. We need to cut the arc on the locus line. Okay. So cut it, and you can mention this as O1. Now connect from O1 to O. Okay. And then extend and find out the beta angle here. So using the protractor, so here the beta angle we will be getting, it is exactly 41 degree we'll get here. Angle of 41 degree. Okay. So here the beta angle, how much we got? It is nothing but angle of 41 degree. So we can mention. Now we need to copy the diagram. So this second position top view we need to copy on the O01. Okay, this one we should copy here. So you can see we have already O01. Okay, on O01 we have to copy the diagram. Okay, using the compass I'll be constructing this top face first and then the bottom face. So measure the length using compass from O to D here. O to D and O1 D1 both are having the same length. I'll cut two arcs here. First arc is from O to D. I'll mention that D, and same length it is there, right? So I'll be cutting another arc without changing, that is O1 D1. That is also of the same length. Okay, you can do that like this. You can do O1 and D1. Okay, now using from O to A or O to E, you can say O to E and O to C, these two lengths will be same. We can cut two arcs here and here. Now from D to E, because you have the D point, right? D to E and D to C, these two lengths are also same. Just cross check it, same lengths. Now cut those first arcs, this one and this one. Okay, and we need to mention its naming here. So this is E point and C point. So mention. If it is not cutting properly, you can do it. Yes, now it is cutted. This is your point number E and this is point number C. Okay, now we have to cut the arc from O to A and O to B. These two lengths were same, OA and OB. So cut it, OA and OB. You have to cut. Now we can cut from D. Okay, we have that reference point, right? D and DB, we can cut it from there to here and here. Can mention the naming as A and this is B. Now construct the pentagon. Connect all these points using scale here. So connect all these points here. We'll get the pentagon. And same way we need to do it for the bottom face also. Using O1 and D1 we need to construct the lower pentagon. So measure from O1 E1 and O1 to C1. Cut it here and here. Now from D1 to E1 and D1 to C1. Here and here you can cut it, and these 2 points you can mention as E1 and C1. Okay, now again from O1 to A and O to B, these two lines will be same. cut the arcs here and here. You can subscribe to my channel and hit on the bell icon for the latest notifications, and share to maximum students so that they can be benefited. So cut this arc. So finally we get it A1 and B1. Okay. Now again construct the pentagon here. So however it is there in the second position top view, we need to maintain the same thing. Wherever there is a continuous line, we'll draw with the continuous line. Where there is a dashed line, we'll connect with the dashed line. So construct the pentagon here. So in the same way we have to construct. Wherever there is a dashed line, we need to construct with the dashed line. Where there is a continuous line, we should be constructing with the continuous line. Okay. Okay. Now we need to construct the final diagram. For this we should be drawing the projection line upward. So to draw easily, you can see, consider top face here and here. So first you consider these top faces and write the notations, so that it will be easy to write the notations. Okay. Otherwise there may be chances of confusion. So you can see here from A I am drawing a line here, projection line, A and B, vertical lines. Straight lines you just draw. Okay, don't get confused that it should be merging or not merging. No need to consider anything, just draw the horizontal and vertical straight lines. So these 2 points are nothing but A dash and B dash. Okay, now same way we will be drawing the projection lines from E and C. Okay, from E also you draw the projection line. That is E dash. Same way you draw the projection line from that C end. Okay, draw the horizontal line properly. That is your C dash. Okay. Now same way we need to construct D here. D and D dash, where it is merging, we have to see D and D dash merging at this point. This is we call it D dash. Now finally O and O dash, we need to connect O and O dash. This is your O dash here. Okay. Now from bottom face also we need to do the same thing. D1 dash, draw the projection lines and connect and try to write the namings so that it will be easy. Okay, by following this procedure you can finish up the problem in less time. Okay, you can subscribe to my channel and hit on the bell icon for the latest notifications, and share it to maximum students so that they can be benefited. So particularly these problems are very useful to the first year engineering students throughout the world. They can benefit it by solving these types of problems. Can write the notations like this. Okay, and finally we have left with O1 dash. So you can project it this also. Okay. And this is your O1 dash. Okay. Now here to procedure to construct the final diagram, here it is. First you need to construct the base here. So here in this problem it is pentagon. So we'll be constructing a pentagon. If it is a square, you can construct the square. If it is hexagon, you can construct the hexagon. Okay. So try to connect all these points. You will get a pentagon here. Okay. Now we can see from the pentagon, so when we try to join the vertical edges, so vertical edges which are coming outside of the pentagon are continuous lines. If the vertical edge coming inside of the pentagon, that will be the dashed line. Okay, you can see from E1 dash to E dash. Okay, it is passing inside of it. So that's why we are going to draw the dashed line here. Okay, the remaining lines will be continuous here because all the lines were passing outside. I'll be drawing those lines. Okay, you can see here E dash is the dashed line. E it is connected with A dash, that is your first dashed line. E it is connected with D dash. E dash, A dash and E dash, D dash is the dashed line. Now all the lines here, that is vertical edges, we should be constructing with the continuous line here. Okay, that is the procedure here. You need to see whether the lines were going inside of the base of the pentagon or outside means continuous line, inside means the dashed lines. Okay, so that's what the procedure is very simple. You can follow these steps so that you can easily able to complete the final diagram. Okay, so finally the left one, it is the axis, that is from O1 dash to O dash, draw an axis. Guys, thank you all. Thank you for watching the video and share it to maximum students so that they can be benefited. Thank you all. Okay, we see another problem in hexagonal prism. So you can see that we have to construct an hexagonal prism dimension 25. So hexagon of dimension 25, axis length 50 mm. So rests on HP on one of its edges of the base. So we have to construct an hexagon with respect to the base edge on the right hand side. Draw the projections of the prism when the axis is here. So when the axis is inclined to HP at 45 and VP 30. So when the axis is given means it is an beta angle problem. Okay. So first we're going to construct XY line. Okay. So this is VP, HP and Y. So we have to construct an hexagon here with respect to edge. Dimension 25. Okay. So it is 60. Okay. So now can take a dimension of 25 and we have to cut the arc. So this 25. Okay. Again can keep the protector here. Mark for again 60 degree. Okay. So here also mark for 60 degree. So here also we have to cut 25, already we have cut it. Okay, so we have to this. Okay. So we can write the notations now. A, B, C, D, E, F. Okay, bottom face notation B1, C1, D1, E1, F1. To find out the center of the axis, we will draw thin lines. Okay, thin lines, thin diagonal lines we will be drawing. Okay. So exactly at the center we have O and O1. Okay, now projecting this. So axis length is 50. So here so for the top face notations we'll write A dash, B dash, C dash, this is F dash, E dash and D dash not visible. Okay, similarly A1 dash visible, B1 dash visible, C1 dash visible, but F1 dash, E1 dash, D1 dash not visible, O1 dash, O dash also not visible. So now we will go for the base edge inclinations, that is 90 minus inclination to HPT is 45. So 45, that is we get 45 here. Okay, so here we have C1 dash and D1 dash. So we will keep the protractor here, mark for 45 degree. Okay. First arc, second arc, okay, so we can write this is our A1 dash, F1 dash, this is B1 dash and E1 dash, this is O1 dash. So these vertical lines are exactly perpendicular to this, so we can mark it, taking a reference of this we will be marking at 90 degree. Okay. Now drawing a line of length 50 mm. So now we can join this. Okay, so I can write A dash, dash, this is B dash and E dash, this is C dash and D dash and this is O dash. So by extending this, okay, here we can show an axis. So if you measure the exact angle you will get it here, it is exactly 45. Okay, 45 degrees. So now by projecting downward, okay. So by projecting the lines from both sides, first we'll write the notations. Okay, so here, so this is A, this is B, this is C, this is D, this is E, this is F, and at this point we have left this point, it is O. Similarly for the this is for the bottom face, right? A1, B1, C1, D1, E1, F1 and O1. Similarly for the top face also we can write. Okay, so this is A, B, C, D, E, F. Okay, this point is O. Okay, we know how to construct the second position top view. That is, first we have to construct an outer boundary line here. Okay, first we have to construct outer boundary line. This is connecting here. Here and this outer boundary line it is done. Now visible space, as it is looking from the top view, we are able to see this face and this. Okay, so the top hexagonal face it is visible. So we write the hexagon here. Okay, and this rectangular face also visible from the top view. F1 and A1 visible from the top view, but this base of the hexagon not visible from the top view. So part of it is written with the dashed line. Okay, and then this rectangular face C dash, D dash and C1 dash, this rectangular face also not visible, so we can show part of it here. Okay, and we can show an axis here, so this is an axis line. Okay, so now, so this is an angle of inclination to VP, it is 30 degree, but so this problem it is an beta angle. Okay, so here we have, this is having 50 mm, right? So this is your first axis length, and this length, okay, from O1 to O, this is your second axis length. Okay, considering these two axis length 1 and 2, we can, so 1 and 2 we can done the third position. So herein we will take here the axis line here, so this is mark reference point, then marking reference point will be marking at this 30 degree angle line. Okay, so axis line it is drawn, it is 30 degree. So what is the procedure is, first we have to take this 50 mm axis length. Okay, you can extend this. First I will take a reference point of O and I'll be measuring this axis length first, that is 50 mm, measuring 50 mm. And cut the arc. So this point it is O2. So after drawing this point you have to draw an locus line here. Okay. Then after that you have to cut the arc from this, from O to O1. And the arc, so this is O1. So now you join this then axis and then extend and find out the beta angle. So here for this we are getting an beta angle of around 40 degree. Okay, now we have to transfer the diagram. Okay, this diagram here. So here you can see that we have 2 points O and O1. Using these 2 points we have to construct the rest of the diagram. So here we have this O point. So I can construct this from this O and O1. You see that O and O1. So I'll be constructing the rest of the diagram. So from this O point, O to F and O to A, these 2 points are same. We'll be cutting 2 arcs. Okay. And then I'm cutting from this O1 point to F, O to F and O1 to F. Okay. So this point it is F and this is A. Similarly, you can cut this O to E and O to B. You can see that these 2 lengths are same. Okay. So from this point only you can cut it. We have 2 points. Okay. F to E and A to B. See, this is B. Again we can cut this O to D and O to C. Okay, now reverse it. F to D and B to C. This point it is D and this point it is C. Similarly we have to construct this one from O to D and O to C1, O1 to D1 and O1 to C1. Okay, and from here again reverse it is O1 to D1 and O1 to C1. So this point it is D1, this it is C1. Now O1 to E1 okay. Now from D to E1 this is E1 and B1, and again from O1 to F1 and O1 to E1. Okay, now from here E1 to F1. Okay, then B1 to E1. So this is F1 and this is A1. Now so we have to join this from these two hexagons. First we complete these two hexagons, then we'll join vertical edges. Okay, so now we have to finish the final position. To construct the final position, here we have to consider two nearest point. Okay, so before that, first we construct this final notation, this one and this one, top face of this front view, top face of this. Okay, first horizontal line projections. Okay, now we will do one by one. So till here, so this point it is A dash. Now here we have, so this point is B dash, and similarly we have this point, and this point it is C dash. Okay, C dash, and D point it is this is D dash, D dash, and we have this point is F dash, and exactly the center we have this point, this is O dash. Similarly for the bottom face also we do it. Okay, so this point is E1 dash, B1 dash, C1 dash, D1 dash, this point is E1 dash, and this point it is F1 dash, and we have this point it is O1 dash. Okay, so here you can see that the nearest edges are E and D, so I will write here nearest two points to xy. Okay, so that is E and D. So E point you can see that is near connected to E to D and E to F. Okay, and then E to E1. Okay, E to E1. Similarly we have D. D is connected with E, D is connected with C. Okay, and D is connected with D1. So these are the dashed lines. Okay, first we are going to complete the dashed lines here. Okay, E to D, and that is E dash to D dash. Okay, and then E to F, you can see that. Okay, E to F. And then E to E1, E to E1. Okay, now we have D2 is done, D to C. Okay, now D2 D1. Okay, so these are the dashed lines done. Now we will complete the base of the hexagon. Okay, so in this base also we'll complete it. Okay. Okay, now from A dash to A1 dash, and then from B1 dash to B1 dash. Okay, now finally we have axis. Okay, so this is how we complete the problem.